Hi, this is Justin Mansell from Active Optical Systems, and this is a tutorial on how to use the AOSViewer software. When you run the AOSViewer software, you'll see in the top left corner a list of the cameras that are currently attached to the computer. Right now, this software is only compatible with the Allied Vision cameras, and I've got an Alvium 1800U-500M, so it's about a 5 megapixel monochrome camera that's running off of a USB port. You can immediately then, once you've selected the camera you want to use, click the Start Image Acquisition, and it will show you here the section of the image that is being displayed down on the bottom right. In the top right, it will show you either the position, size, a histogram, or a power in a bucket curve, depending on how you've selected the tabs. On the left is our inputs, and so in this case, on the Draw tab, I've got exposure. So I can actually bring the exposure up on this camera. That's too much, maybe in here somewhere, and you can actually make out the structure of the wall there. I'm running it in track mode, so that's why it looks a little jittery. So let me turn track mode off, and you get a nice stable image. This camera is just sitting on a tripod looking at the wall. You can also, if you look carefully, see that there's a beat frequency between the LEDs that are illuminating the office and the camera acquisition. Adjustments can be made to the camera to mitigate that. I haven't done that for this demonstration. And so if you look carefully, you can even see that it looks like it's bouncing up and down, and that is showing up here as the Y centroid moving up and down a little bit. So I am going to bring this back down because I'm not interested in tracking the wall. I'm actually interested in tracking a laser pointer on the wall. And I'm going to put it back into track mode. And of course, it's bouncing all over the place now. These plots, by the way, are showing you the coordinates and size calculated by the first and second moment using this relative threshold at 25%. And it's doing that with respect to time, and then the time axis here is shown there. And so there's this funny little beat frequency again with respect to the lights and the camera acquisition. So now if I paint the wall with a laser spot from a laser pointer, and this isn't terribly bright, let's bring this up a little bit more. There we go. Now I can kind of see that. You can see that I can move, because I'm tracking, the active and displayed image around inside of the box at the top left on the display side. And so I'm moving this around nice and slowly, and you can kind of see not only is my first moment changing, but I'm moving this red box around as well. It's not moving down here because I've turned tracking on. If I turn tracking off and just move it around a little bit, you can see that I am moving it because the spot's now moving and the first moments are moving around, but it's not keeping that spot centered, so I'm going to turn tracking back on because I prefer to have that on for a lot of the alignment purposes that I use in the lab. You can average images, so I will show you that. Here I'm averaging with a running average factor of 0.3, and so you can kind of see the previous images. I'm going to turn that off. You can also do a power in a bucket curve. And so if I click graph power in a bucket, it'll take 3 frames. And if I stabilize the beam very well for 3 frames, it will show me the power in a bucket and the average power in a bucket centered and not recentered as different. So now I can also turn on color bar processing. And so this is going to apply this color bar to the image. I can change the scale on that, and I can bring up the minimum, and that will get rid of some of the background. I can bring it back down, and it'll show back up again. I can change the maximum to 25, and now you can really see that background showing up, and bring it back to 255, and here we are looking like it did before. The color bar processing does take some extra time. I'm going to turn that off. I'm going to turn the rescale off as well. Let's go back to taking a look at the size. The size calculations are showing that the beam is pretty small, except for when I accidentally walk it off of the frame and things like that. And so if I hit reset on that, you can see that I'm seeing, and also it's affected by the fact that the wall isn't a perfect scattering source. So I can bring this up a little bit and try to make that a little better. Here is the histogram. So if I turn off the laser spot, I've got a lot of pixels that are reporting in the very low counts. Turn this back on, and now I'm starting to see some pixels show up in the higher count values, including some that even get up to saturation if I just hit the wall correctly. So that's the basics of how this works. You can also use it for alignment purposes in the lab. So here I put the spot onto approximately the center of the screen here, and I hit save, and it will create, in this case, a green mark that I can see relative to the current position. If I want to do another one, I can just hit the save button, and there's the blue mark. If I want to draw an alignment mark, in this case, I'm tracking that alignment mark. I'm not using the coordinates specified here. This is a 16 by 16 pixel alignment mark. It's sitting around the outside of the spot because it's tracking that. I can also draw a red circle for the size. I'm going to turn off the laser pointer so you can see that the second moment gets very big and it's drawing a very big circle. Turn that back on, and now it's drawing a very small circle. I can turn off the size drawing and turn off the alignment mark drawing just with specifying clicking on these checkboxes. You can also save a series of images. So I'm going to change this to 10. I'm going to record 10 frames, and if I hit the DAT, it'll ask me, well, where do you want to put these? And it'll specify a year, month, day, hour, minute, second section of the file name. I'll hit save, and it will then start the recording, and there it is. It's done with the recording. It is recording those with the processing continuing to happen. I can go here and turn off the processing to get a little better frame rate on those. Of course, it then, and I've turned off the laser pointer. Let me see if I can get that back onto the image here. There it is. It is much faster in terms of acquisition without the processing. The processing does slow it down a little bit. You can also snap an individual frame. So I can snap an individual frame, and it shows me where down here it's saving those frames. It's to the pictures directory, and there's 3 different versions of it. One is the as drawn on the screen, and then there's a couple of raw ones. And then you can also run something called Vimbo Logger. Vimbo Logger creates a .dat file from the array of images taken, and it is much more rapid because it does no processing, and it just dumps the files to disk. So I hit Vimbo Logger, you can see it is running and it's done. That was only 10 frames. Let's do 100 frames, and Vimbo Logger, there we go. It's about 38 frames a second, it said, and it saves that out. And so Vimbo Logger is good if you want to set everything up here and then take an array of frames very rapidly. There is some capability to set up a TCP server and serve the images over the TCP link. I'm not going to brief that here. It's more of an advanced feature. If you need more information on that, please contact us at AOS. But that is a quick introduction to the AOSViewer. If you have other comments or questions, don't hesitate to reach out to us. Again, this is Justin Mansell from Active Optical Systems. Thank you all for listening.